Hey guys, this video is 4.1 matrices and data. In this video, you're going to learn about how to add and subtract matrices. You're going to be able to determine the dimensions of a matrix, and you're also going to be able to notify what is the address of a matrix. Also, by the end of this, you're going to be able to do scalar multiplication. Next video is going to be about multiplying matrices. And so to discuss what a matrix is, no, it's not the movie The Matrix, where you take the blue pill or the red pill. That would be sweet, but no. In this, a matrix we're going to discuss and we're going to talk about it. It's going to help you really at the end of the day, in the future of this class, you're going to be able to solve systems of equations with matrices. So let's jump right in. The number one thing that I'd like you to know by the end of this is what are the dimensions of a matrix. You must be able to determine the dimensions of a matrix immediately. As soon as you see a matrix, you should be able to tell its dimensions. Now, the dimensions of a matrix are m by n. Okay, m by n. The dimensions are extremely important. You must know this about them. It determines how to add or subtract, or can you even do that, and how to multiply matrices, or can you even do that. So the dimensions of a matrix are m by n, meaning m rows by n columns. And m and n are just numbers. Since they're just numbers, we say that there are m rows by n columns. So let's do an example and see what the dimensions are of this matrix. So this is 1, 2, 3, 0, pi, negative 1/2. No, Mr. Blair, there's fractions in pi. Yeah, in matrices, you can have any sort of number, rational, irrational, does not matter. So how many rows are there in this matrix? Well, there's 1, 2 rows. Oh, by the way, if you don't know rows from columns, that's not good. But rows go this way, columns go up and down. So there are 1, 2 rows, so there are 2 by, well, how many columns are there? 1, 2, 3. So this is a 2 by 3 matrix. Your eyes are not playing tricks on you. The camera does not want to focus. Come on, camera. Oh, yeah. So this is a 2 by 3 matrix. 2 rows, 3 columns. Let's do another example. Let's do this one here. 1, 3, 0, negative 1, 0, 1. Well, how many rows are there in this matrix? 1, 2, 3. And how many columns? 1, 2. So this is a 3 by 2 matrix. Okay. Now you can also have matrices that are called square matrices. Let's do something like this one. A square matrix just simply means that the dimensions are the same. So the rows and the columns equal each other. So this is a 2 by 2 matrix. So that's how you simply find the dimensions of a matrix. You must be able to do that. When you add or subtract matrices, the rows and columns must be the same. They must be the exact same dimension in order to add or subtract matrices. We'll get to that in a few minutes. Okay, now let's talk about an address of an entry. Now what this means is simply it's the location in a matrix that an entry, so like this number 1, that's the entry, but its address is unique. This number 0 is the entry, but its address is unique. Your address is your location. My address is, that's creepy, I'm not going to tell you. But the address is the location. So if we check this out, this right here is an entry. So we're going to see, well, what is the address of this entry? Well, in order to tell what an address is, we use this lowercase a and then subscript mn. So the address is at m row nth column. So for this guy here, well, what row is it in? It's in the 3rd row. And what column is it in? It's in the 1st row. So this guy, this entry 0, is at the address a 3rd row, 1st column, A31. And so that would be how you would determine what is an address of something. So let's do with a couple more. This guy here, this is what is its address. Well, it's A. It's in the 1st row, 2nd column, so it's A12. And that's simply how you do it, not a problem. This guy here, pi, what is its address? It is A 2nd row, 2nd column, A22. And that's what you do. So if you have a matrix, you can look at it like this. The address is found A11, A still in the 1st row, A12, still in the 1st row, A13. Now we're in a different column. And you see this goes on and on and on forever. I think I need to get glasses for this camera. Okay, so Come on, dude. So here we have A11, A12, A13, and then if we would have A21, A22, dot, 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 and then A31, dot, dot, dot. And that's how you determine the address of a matrix. Okay, that's it on addresses. Now, we're also going to discuss adding and subtracting matrices. This is extremely important. You follow these rules that I'm about to tell you. Adding and subtracting matrices. When adding and subtracting matrices, you can only add or subtract them if the two matrices have the exact same dimensions. They must have the exact same dimensions. You can never add or subtract them if they do not have the exact same dimensions. So let's do an example of this. Let's say that we have this matrix here, 2, 1, 0, 3, 1, 1. Well, let's first determine what are the dimensions of this. Well, the dimensions of this guy are, it's 2 rows by 3 columns. You're probably getting blurry this entire time. Don't worry, Mr. Blair's only getting really mad as this is happening. He's probably going to flip out halfway through this video. This is frustrating, so let's try to fix this guy. All right, if we're going to take this matrix and we're going to add it to another matrix, well, that's as focused as we're getting right now. Too bad. If we take this next matrix, 1, 1, 3, and 0, 4, 2, well, what are the dimensions of the second matrix? Well, there's also 2 rows, and there's also 3 columns. So you can add these two matrices. They have the exact same dimensions, so we're good. When you add them, all you do is you're going to get the exact same dimensions. So my matrix in the end is going to be 2 by 3 also. And all you need to do are add the entries with the same address. This is A11, this is A11. We're going to add them together. So this matrix is going to become 2 plus 1, 1 plus 1, 0 plus 3, 3 plus 0, 1 plus 4, 1 plus 2. And as you guys know, Mr. Blair loves taking points off if you don't simplify because that makes him mad. Don't do that. Simplifying at 3, 2, 3, 3, 5, 3. This is still a 2 by 3 matrix, and we've added now 2 matrices. And that's it. Now here's the thing. If I had 2 matrices like this, let's say I did this example, and we had 1, 2, 3, 0, 1, 4, and we were going to add that to this matrix here, 1, 2, 1, 0. Well, the dimensions of this first matrix are 3 by 2, and the dimensions of the second matrix are 2 by 2. This is not possible. These 2 matrices do not have the same dimensions. Therefore, you cannot add or subtract them together, and that's it. So when we're talking about adding or subtracting matrices, all you have to do is simply take the addresses of the same from each matrix and combine them together. Whether the rule is adding or subtracting, that's what you have to determine also. So let's do a couple examples, and I want you guys to do these right now. So check out these right here, problems 1 through 3. I want you to pause the video and answer the question, what are the dimensions of the following matrices? Go. Now you probably didn't press pause because you're a slacker. Now I want you to press pause. Do it. All right. The dimensions of the following matrices. Well, there's 1, 2 rows, 1, 2 columns. This is a 2 by 2 matrix. There's 1, 2, 3, 4 rows, 1, 2, 3 columns. This is a 4 by 3 matrix. Obviously, that's a pretty big matrix. We're going to see big ones all the time. You might, for the most part in this class, maybe see up to 3 by 3 or 4 by 4s. Okay, this is 1, 2, 3 by 1, 2, 3, 4. So it's a 3 by 4 matrix. Okay. Now what I want you to do is take these matrices right here, and I want you to add or subtract them if possible. Okay, pause the video, and I want you to do B plus D, B minus A, and D minus B. And these are your four matrices right here, A, B, C, and D. All right, so let's check this out. I'm going to determine the actual dimensions first. This one is a 3 by 2. This one is a 2 by 3. This one is a 3 by 2. This one is a 2 by 3. B plus D. They have the same dimensions, so we can add those together. So this is going to become 4 plus 0 is 4. Negative 1 plus 1 is 0. Negative 5 minus 13 is negative 18. 3 plus 3 is 6. 2 plus 0 is 2. 8 plus 10 is 18. And this is my new matrix, B plus D right here. Okay, and that's how you're going to add and subtract matrices, just like this every other time. Now B minus A, let's try to do that one. B minus A, well this is a 2 by 3 matrix minus a 3 by 2 matrix. This is not possible. Okay, now let's check out D minus B. D minus B, all right, well 0 minus 4 is going to become negative 4. 1 minus negative 1 is going to become 1 plus 1, so that's going to become 2. Negative 13 minus 5 is going to become negative 13 plus 5, which is going to become negative 8. 3 minus 3 is going to become 0. 0 minus 2 is negative 2. 10 minus 8 is 2. And that's D minus B. So check your work. Make sure your algebra is all good in these. As you saw from earlier in Chapter 3, algebra skills are super important in the stuff we're covering. Now let's move on to scalar multiplication. Okay, scalar multiplication is as follows. Scalar is just a word for a number. It just means a number. So it means you're going to take a matrix and multiply it by a number. For example, we might have a matrix, or the number 3, which is the scalar, and multiply it by this matrix here. All you need to do is take each entry. This camera is going to make me scream. Take each entry and multiply it by 3. So this will become 3 times 1, 3 times 1, 3 times 2, 3 times 2, 3 times 0, and 3 times 4. And so the new matrix, after you simplify, is going to become this one here. 3, 6, 3, 0, 6, 12. And so this is what scalar multiplication is. So if you take a matrix and you multiply it by a scalar, all you need to do is simply take the number, multiply it by each entry, and that's all you have to do for this. Okay? So let's do a couple examples right now. Look at that. The camera's focused. If it goes that blurry right now, I'm going to scream. I want you to try this. Try to do 3b plus 2c. Pause the video. Try to do these right now. This matrix is a 2 by 2. This is a 2 by 3. This is a 2 by 2. And this is a 1 by 3. So 3b plus 2c is going to mean 3 times this matrix here, which is 4, negative 1, negative 5, 3, 2, 8, plus 2 times the matrix C, 3, 2, 0, negative 9. Can I add these matrices? No, I can't add these matrices because they have different dimensions. So this here is not possible. Now the next one, 2a minus 3c, well, a and c are both 2 by 2 matrices, so that's good. So we can do 2 times a minus 3 times c. Well, 2 times a is going to become 8, negative 4, negative 6,